Welcome to the second in our series of videos. We review the bio-decontamination process using VHP in GMP manufacturing environments. Today we continue by getting insights from our subject matter expert James Drinkwater, who is head of GMP compliance at Francil. James, can you provide a scientific comparison between VHP and the so-called dry fog bio-decontamination processes?
Yes, indeed. VHP is a condensable vapor generated by flash evaporation on either firebars or hot plates. It's a biphasic process, and there's a gas phase and a condensed vapor phase. In the condensed vapor phase, when molecules deposit on the surface, there's a continued dynamic exchange with those surfaces. In contrast, dry fog actually creates droplets by pressurizing an agent through a nozzle. As such, these droplets are in the 8 to 12 micron range. The flash evaporated molecules are in the pico range, 10 to the minus 12. If you looked at a size comparison between these two, the molecules would pass easily through Tyvek and HEPA filters. The droplets would not directly pass through. This means there's a real difference in the application of peroxide on surfaces. We also see, if you look at the scientific comparison between the size of the molecules pico and the micron, if you look at a golf ball as pico, then the size of the Empire State Building is the micron aerosolized droplets. That gives you an insight to the scientific comparison, the non-comparability between the two processes.
Thank you, James, for the clear comparison. Let us now move on to another important aspect. How do you manage biocompatibility issues when using VHP in the manufacturing of biological products?
Classical endpoint of a VHP efficacy cycle is 1 part per million. That's the OEL. That residual is about safety, is not about process compatibility. So we need to characterize the aeration endpoint where we're talking about biological products, which are extremely sensitive even to below 1 part per million. So typically the endpoints are characterized in the 0.1 or 0.3 parts per million range because of this sensitivity. The high oxidizing potential impact we have to consider. Genentech pioneered an assay of Amplex Red, horseradish peroxide, to able to look at the characterization of this process. So we can understand, we can develop the endpoints supported by data. Now in Francil laboratory, the chemistry laboratory, we have taken on this Genentech pioneered method and use Amplex Red to support testing of establishing data for the endpoints of cycles for biological product manufacturing. This is really important to prevent VHP contact with the product. But also we have to look at single-use systems and any penetrative barriers like the packaging in single-use systems. So we can use Amplex Red for that characterization as well. The penetration barrier validation. All of those come from that application. For the gas phase endpoint, we now need to look at more sensitive analytical instruments, and we use Picarro. This takes us into a limit of detection down to 10 parts per billion, so we can really make sure that we have a very accurate endpoint analysis. Thank you.
Thank you, James. Don't forget to join us for the next in the series, where we will discuss rapid VHP bio-decontamination cycles for material transfers, VHP process monitoring for cycle validity verification, and optimizing total cycle times. See you next time.